Okay, hello everyone. Welcome to another Wolfram Language Design Review. This one is about dates and times and related things. That's not a moment too soon. That from date string got much faster. So date object of a string is
Yep.
now
Yeah.
much
So
faster.
yeah, from date string is our endpoint function, but there's all the date functions that take strings get faster. And as that first note says, we added support in tabular for these things, and that's a motivating factor for a number of the improvements. Is that if it takes a millisecond to go from a date string, that's a little
Sure.
annoying. But when we have a million strings and we need to convert them, it needs to be
Right.
sub microsecond. So
Okay, conform dates. Okay, so this is
yep.
along the lines of conform images and so on.
Yep.
Yes.
Mm-hmm.
I mean, you should write out in this documentation list date one, date two, date.
Okay, yeah, I'll make that change. And this is another thing that, internally for working with collections of dates, we have to do some homogeneity anyway. And so this framework works both for automatic cases. I have a bunch of dates, just make them the same for me. And also for I have a bunch of dates, I want them all to look like this, or I want them to look like this specific date.
What are the possible settings for D type?
So that
Doesn't
basically
say. Oh,
I
down
mean,
there.
yeah, so that section needs to be updated. It's basically consistent with the element type used in a tabular column. So the idea is
Okay.
that for generating things like a tabular column, it might be nice to just directly generate it from a list of dates. um,
Somehow we have all these conform functions, images. I don't know if we have one for geopositions, but we might have. Maybe we should, standardize the conform, some kind of conform list or something. Does that make any sense? I mean, I can
yeah,
imagine other conforming type things that we need too. Go ahead. What are you going to say?
yeah, I was going to say we also have, it's an older function, but common units is a similar thing for quantities. Give me here's a bunch of quantities, make
Yes.
them uniform.
The only issue, I think it's nice to have a unified thing, but what if there's individual controls that needs to sort of speak dates or speak
Yeah, I understand,
images?
like calendar type and so on.
Yeah.
I'm not sure that that is necessarily incompatible with that. I mean, although I agree it's harder to document if we do that.
Yeah.
But
Yeah, I think they should be uniform, at least in their argument structure and argument handling. But yeah,
I mean, there's also, we don't have conform times yet. That's also a thing. I mean, this does that. I mean, we're using date as a generic for date and time anyway.
right, yeah.
Renaming the default time system to UT. That's not going to have backward compatibility issues, is it?
Nope. Yeah,
No.
we accept both of them. We're just standardizing the naming convention we use to be UT because it works better for far past dates than smeared UTC, where UTC didn't actually exist.
Right.
Yeah, it was a wrong choice of name. It became clear when working with eclipses, we needed this time system very far in the past and the future, and it was very weird to have, I don't know, UTC 2000 years in the past.
Fair enough. Okay, which are we using by default for printing? Let's see, if I say date object of my up minus
That's going to normalize the zeros, but we're using BC, and you can
why
see
is there no
the
space before the BC? Or maybe I'm just wrong there. I mean,
there's a thin space. This is one thing that we changed after making our previous discussion, was that when the BC was the same size and spacing as the other elements, it started to look awkward, particularly if you include something like a time. A lot of far past dates won't include an hour, but once you start
hard to believe
including,
that there are any ones that do,
yeah,
except eclipses, perhaps.
yeah.
I don't know. I don't really believe in BC being small. It's really pretty much the main event here.
Mm-hmm. So if you do date string of that, you'll get the So for like date strings, we want to keep things ASCII as much as possible. Oh, actually,
That's wrong.
yeah, this is
That's
in
a
the
bug.
prototype version. Yeah. So if you do date string of that input instead of the date object itself.
Well, obviously, it's just going to say BC. Yeah.
Yeah.
But
So
is it too far? So we have been discussing quite a lot whether that space between 68 and BC should be there or not.
I think so.
okay.
I
mean,
don't see.
that's
I mean,
easy
I
enough
you
to
know
do.
when I see dates written, they're written with spaces there.
Yeah, that's consistent with what we saw in other places. So yeah, I can revert that.
I
really
think you
easily.
have 68 space and BC in big letters.
Okay.
BC is really important. I mean, it's kind of like, 1900 BC is very different time from 1900, AD, CE, whatever.
And now that
other-
we are looking at this, Lou has pointed out that the font we have now is too small. So can you for a moment go back to 100% and check whether you are okay with this size? In terms, Lou believes we are overdoing this.
Well, we don't want it to be taller. The whole aggregated thing doesn't want to be taller than than the rest of the line, right?
Mhm.
So that's the issue. Now, that's a question for design. I don't think it's obviously too small.
Okay.
But we can maybe iterate that once with design.
Okay, I'll touch base with Jeremy again. One minor thing that you had requested, if you do date interval of today. So there used to be a calendar icon there. We removed it because you didn't like it. I just want to make sure this still looks good without an icon there.
Yeah, I think it's okay without an icon.
Okay.
The sub-second, I mean, we going to femtoseconds or something, or what are we going?
We currently support up to picoseconds. So if you open the number 4 in the details below, there's a more comprehensive breakdown. We theoretically can support up to attoseconds in the future. Right.
Why do we care? I mean, that seems very obscure.
It is. I mean, current technology has clocks reaching 10 to minus 18 seconds. I mean, it is the best that can be done.
So there are attosecond. So you're telling me there are attosecond accurate?
Yes, there are some atomic, some modern versions of atomic clocks can reach really
But
much.
is that connected to the absolute time system, or is that time differences and things? Because time differences are going to be 75 attoseconds, and that's in the unit system.
Yes.
This is, times anchored to global time.
Exactly. Yeah, this is granularity in dates, what we are discussing here.
Right. And I mean, I don't see that as am I wrong? Is there an atomic clock that's broadcasting,
No.
attosecond level
No.
stuff? I can't
No,
believe
no.
it. How far does it get? I mean, I have to believe it's not far beyond microseconds.
Well, certainly they reach nanoseconds, but no, certainly not attoseconds and even more.
Okay.
So one thing which I think if there's going to be something you have an objection to here, it might be these numeric granularities. So we have decisecond, centisecond, millisecond, all the named seconds down to picoseconds. But there are instances where you may want, 10 to the minus 5 seconds. We don't have a clear name
Really?
for
What are
that
those
unit of time.
instances?
So a more common instance of that would be like in typesetting, if you want to show 5 digits of precision or 6
I
digits
see.
of precision.
Okay, so that's a precision number, basically. So is it consistent with n's precision? So if I say date object of, can I give an absolute time here, or do I need to
Yep,
give?
you can give an absolute time.
What the hell is that? -5 there.
So that is our type setting because we don't have a name for that granularity, right? It's 10 to the -5 seconds.
Well,
Or
S
10 to the
-5, that's really weird.
I mean,
Why do we need to show that? By the time we're showing a certain number of decimal digits, doesn't that define the granularity?
it does, but I mean, if you are with 12, it may be difficult to count.
Tough luck. Well, okay, you're naming that picosecond.
Yeah, we know picosecond, but if you do 11, there's no name for that unit of time really. So we
Well,
could.
then what
align
I
the
would call it
granularity.
is 10 ps colon. If you want to do that, S to the -11 doesn't cut it for me.
I see.
Okay.
Yeah, that's a good idea.
Mhm.
I mean, if we need to do it at all, I would argue that you've got the granularity information in that digit count. And I just don't think how would I compute the sort of date granularity? Is there a function? How do I get out the date granularity? Is it date value? Is there a date value?
Yeah, date value, and you can say granularity is a string there.
What the heck does that mean?
So this is an instance where the granularity, we don't have a granularity string for 10 to the -11 seconds. It's the literal representation we're
Oh,
using.
what the heck is that? What the heck is that? Help. It's an undo problem of some kind. Somebody should report every, maybe you can capture and report that.
Okay.
Yes. Yep, got it.
Yeah,
Okay.
I have it.
Tell me any other things that you're doing that are, because I wouldn't have caught this, and I kind of need to, I want to.
Yeah. So this and the corresponding support in date string. So if you say date string and for the format type, you can say date string of now, comma
11.
Well, not 11 there. So if you were to give a list and say, time, comma 11.
I'm sorry, what is, can't I give that?
You can give minute, yeah. But if you give a list as the second argument and say the string time and then comma 11, that will print 11 digits to the right for seconds. These are the only two
Why do
places
you
we're
have to
using
say time, comma 11? I don't understand. What if this works, comma 11? Why doesn't this work, comma 11?
We could do that. It would
I mean, I think it
basically
has to
just
be
be
consistent.
defaulting. Yeah. The reason that we support it in the list case is that you can give an arbitrary format there. But yeah, we could just have. I mean, there's no ambiguity there. And
What's that?
Should give an error message.
So 20 is not supported.
Yeah.
Why not?
Well, we are using real numbers with 18 digits, so
I see.
we decided to leave it currently at 12. This is what we support.
Okay, fine. Okay, so what's it going to say? This is too high a precision or something? Too high?
Yeah,
too
it'll
fine a
say,
granularity?
yeah, the requested granularity is too
It's
high.
not current, is too high.
It needs to be a value between blah and blah.
Okay. All right, but I don't know. Should we use up the second argument really for these? For this.
Well, the second argument is already granularity.
No, I understand that. But okay. All right. But so for date string, what is the second argument?
The date string is the format. So it's either a string for the single element you want, which might be a date format, or a single element, or a list of elements. It can be any of these things. And
Okay,
none
but
of them
aren't
are
these
numeric.
granularities all down here? I see. But when we say locale, short, whatever it is, you know what? I'm kind of agreeing with you that putting in just having a naked 11 there seems like we're using up a big piece of syntax space.
Yeah. What we basically did was saying if the final element in the list you specify is an integer, then we can assume you want that many digits to the right in the seconds.
Yeah. Okay. All right. Fine. I
It's-
mean,
there-
this is
there's
a bit
something
obscure because I mean, in some of these things, month Roman numeral and things like that.
Mhm.
Those are pure formatting, and then we're mixing that with granularities, right?
Yeah, I mean there's some interplay between like the date elements and granularities, right? I mean the date values extractable elements correspond almost one-to-one with what's in date string.
Yeah, except that there's
Mhm.
things like week beginning and things like this
Right.
that aren't
Mhm.
that aren't in date object and so on.
Yeah. And our
Why does
kind of
time, 11 make any sense? Why is that what makes sense as a way to specify granular stuff?
it's
Oh, I see. That's
it's
just
less the
time.
granularity, it's how many digits you want to print. So if you just do time right now, it totally elides any fractional seconds. It just takes the floor. That's what
Yes.
date string has done forever. And there's been no way to specify I want
All right. Okay.
fractions of a second. Up
Are
to
we
this
sure there isn't?
precision.
Don't we have a granularity option in many?
We have a date granularity option in every function that generates date objects.
Okay,
We
so why don't we
have-
have a date granularity option in date string? Or does that not
Generally,
make
we've
sense?
restricted it to things that generate date objects rather than strings.
Okay.
There is one precedent we were following. For example, if you write DMS string here, comma 2, you see
DMS string.
DMS string, comma, bracket here, comma 2.
I mean, comma 2 inside like that.
Yes. So that will print,
Here is the first argument.
just write a geoposition with some random numbers there.
Okay.
Well, use some reals with digits and you will see how this is controlling. But that's too large for a latitude. Right. So you see, if you write now 4, it would use 4 digits.
I see. I know this is asking about set precision on a date object. Does it work? Should it work?
It can work on the values inside the data object. So we aren't and hold.
Okay.
But
Look, I think this
there's
is
a bit of a-
okay. I think this is a slightly corner case, and it's okay. And dramatically faster. Good. Okay. All right. Let's go on here. Quantity Q and known unit Q. What is that now testing?
So the second argument is you can look at the ref page if you want to, but the second argument is a unit dimension specification or a quantity variable.
Why, oh why,
tools.
did that take a long time to come back?
I'd look at the page in DocuTools. It's a little more up to date.
Okay.
So basically, this is useful because for a lot of functions, elsewhere in the system, you want to look at an input and say, okay, is this input a time?
Length. Yeah. Okay.
Is it a length? Is it a time? So this lets us, in a single evaluation, say, okay, is this a quantity of time? Is this a
right? That's
unit
good.
of acceleration?
Yep, that's good.
Yeah, this is very useful to check velocities and it will understand both height and length and distance and all the variants.
Good. Looks nice. Okay. Date distribution. Time distribution. The heck is that? Is that a function that is representing a distribution of dates?
Correct.
Yes. I would look at descriptive statistics first, and then, we can look at those two models for date and time.
What should I look at here? Examples here?
Yes.
So dates are like temperatures. It's an interval scale. So not everything makes sense, but surprisingly much makes sense. So mean is kind of like a date plus a bunch of date differences.
Yes.
So that makes sense. Median is like ordering. So that makes sense. Standard deviation is a bunch of differences squared.
Yep.
Etc. And so as it turns out, there's only like very, very few like moment and factorial moment that doesn't make sense.
Cool.
And just about everything else makes it. If you open up that status table, you'll see. And so this is also driven by tabular because we needed ways to summarize date and time columns.
Yes.
And weighted data means that it computes the weighted statistics. So
I understand.
mhm.
Good. Good consistency case covered.
Mhm.
Okay, date distribution. So what does that mean? Does that mean like I can have a Gaussian distribution of
dates.
no?
Yeah.
Yes. Yes.
So you have to say how the reals map to the dates, and that's basically what the input does.
Okay. So I mean, if I say date distribution, can I run it?
Yeah.
Yes. Mhm.
Okay, so if I say normal distribution
Mhm.
and I say now or today,
No,
comma,
the parameters still need to be numeric.
but that should work.
No,
Why not?
I will disagree with that.
Why?
Because this is a very special case. So, you can have it maybe for one or two distributions that's gonna work. And for that reason, we have the date distribution when you have the normal distribution, which is a distribution of the magnitudes, and then you have the unit, and then you have the origin. In a similar fashion that we have quantity distribution when we have numeric distribution of magnitudes and then the unit. So
Well, okay. So hold on a second. So if I want to say, I don't understand this. Okay, let's take a look here.
So if you take, for example, different gamma distribution, there is no straightforward relation between the parameters and the mean and the standard deviation. And many distributions just have shape parameters, and there is no way to put units or dates there to indicate what it is. So normal distribution, it's a special beast because here, the parameters correspond exactly to some statistics that actually are meaningful. But generally, if you want to have any magnitude, you just put a numeric distribution, numeric parametric distribution.
Okay, so let's say 0, 5 there, and I want that to be a 4-day variance. How do I do that?
So if you do that, if you put days now as a unit, you're gonna have a 4-day standard deviation.
Okay. Okay. And now if I want to do that, that's relative to today. Is there a base here?
Yes, so the third argument is your date origin.
Okay.
So you can put here date object of, yeah.
Well, let's say this now, for example. Okay. And so now if I say mean of that, cool. And if I say variance, well, this is cool.
And it should be consistent with simulating it and computing the descriptive statistics.
Right, so if I say random date.
A random variable for the time being. I haven't supported the random date with the distribution yet.
Okay.
So
random variable?
Mm-hmm.
Variate, rather.
Variate, yes, sorry.
Cool.
So this
and
works.
So if I do, hold on. If I do, let me just try this for a second. If I do this, comma 500, and then I say date histogram of that.
I would suggest not using table, but just adding a second argument to random variate.
Yeah,
because
don't
it's
do
gonna be
table.
very slow in table.
Well, it
So-
worked just fine.
It does work, but it's a slow.
Okay.
Yeah.
Okay,
Mhm.
but it's very nice. That's very
Mhm.
nice. Really fits together. It's great.
So they are both working within the distribution framework. Hence, the random variate is supported, and for the random data, need to add the support there.
Okay, cool. Okay, that's what we just looked at.
Yep.
Yeah, this is interesting for biostatistics. It's clearly going to be relevant. Nice. Okay. Okay. Time distribution.
So
Why do
that's
we need a separate time distribution from date distribution?
because it's on the time objects, and the time object has it's not fixed in the
right.
calendar, right? So it's a 24-hour interval that we're looking at, and by default the time distribution goes from midnight to midnight. So default origin at midnight, but you can also shift it. But it's always gonna be this kind of truncated distribution over the interval of 1 day of 24 hours. So that's why it's different.
Why is that right? I mean, if I just want to represent a disembodied, I see, then I should really be using just a quantity distribution.
Right, because if you do time object of 27, you are back into the loop between 0 and 24.
Yeah, okay.
Mm-hmm.
Nice. Okay. All right, should we move on? That's great. I mean,
Yeah.
Okay.
This is very nice that this all fits together. Very cool. I mean, I hope it's going to fit together with time series and so on properly.
Yeah, I think it already does actually. And it will fit even better in the next generation time series.
So just so I understand, if I have a time series and I say, get me the distribution of, I mean, it's like a time series histogram.
Yeah, it works today.
Okay.
So the date histogram. Mm-hmm.
Yeah, the date histogram.
No,
works
that
today.
works. But I mean, if I want a empirical distribution, does that work?
Of what?
Of a time series.
Well, you have to specify what you want in terms of the values or the dates in a way. Because empirical distribution, it's not a model for a serial data. It's a model for unorganized data. So it will just work on the values.
Okay,
Right.
but so I get the keys and then I could feed it in to that.
Mm.
I could feed the list of date keys
Yes.
into empirical distribution, and then it will work and it will give me a date distribution. Is that true?
No,
I
we could probably make that work.
hold on.
Well, it's a suggestion.
Well, so the thing is that you could so what you can do is you can use the data distribution with empirical distribution as a numeric empirical distribution as a magnitude distribution.
I see.
So you can put it as one of the distributions. It could be normal, so parametric, or non-parametric distribution like a smooth kernel distribution. Yes. Inside. But I don't have here the non-parametric support for dates per se at this point. So that might be something to look, in the next step to look at.
Fair enough.
I have the estimation for the parametric distributions at this point.
Okay, onward to Astro.
Yes, so the important thing here is you probably have, okay. So the main thing here is a change in both astrographics and geographics of the geometric engine. And so here there are two changes. One is that you see that the lines, these planes, the ecliptic, the horizon, etc., now they have ticks. This is using the technology of axis object, and it works pretty well. And it's very interesting to see the ticks that they have. So this helps in orientation. For example, the blue line you are looking at right now is the equator, the projection outwards of the equator of the Earth.
Yes.
And the natural way of adding units there or ticks is sidereal time. So that coordinate there is sidereal time. And And then, for example, the ecliptic, which is in yellow, it has dates. So it's the date of where the sun is. So you
I
move
see.
the first slider, the hours, so that we see the sun. Yes. So now you see
Oh, yeah,
that's
it's on May 1st.
in May.
Cool.
Exactly. Exactly. So as the sun moves over during the year, it will change the date. So that explains what the axis is there. So that is going to project the Milky Way and add it there. And now you see it's along the fourth line, which is the galactic plane. And the tradition there is to use degrees. So the center of the galaxy, again, you have to move the first slider to see, it will be 0. So now it's slower because it has to project again and again the galaxy.
Wait a minute. So I'm now, wait a minute. As I change the hours, at some point I will be looking, the center of the sky will be in the direction of the center of the galaxy. Is that right?
Not necessarily. So at some point, the plane of the galaxy will cross that point. The red line
This
will
is now
cross that
looking
point.
outwards from the out to the outer reaches of the galaxy, so to speak, rather than towards the center.
Exactly. Yep. Exactly. That's 0.
Okay.
And so,
Oh,
yes.
wait a
So
second. So I mean, that galaxies. Oh, I see. This is okay. Go ahead. Go on. You can say.
no, I was going to say that, for example, if you see where the blue and the yellow lines cross, those are the equinoxes. So that's the September 21st equinox. And if you move again, you would see on the other side, you would see the March 21st equinox.
Okay, explain this to me. What I mean, so the sun is always on the plane of the ecliptic.
Exactly, the yellow line.
Right.
Exactly.
And the equator line.
That's a fixed line out in space.
Yes.
And so the definition of the origin of that line, so where 0 hours of right ascension in the blue line, or the 21st is the vernal equinox, which we are not seeing right now because it's on the.
Yeah,
So
I get it.
Yeah, so it would cross on the other side, and that would be the vernal equinox. So what we are seeing here, you are pointing at, is the autumnal equinox.
Why is it obvious that when the plane of the equator crosses the plane of the ecliptic, that corresponds to the equinox?
It's a definition.
Yeah, but the equinox is also equal time, equal day, night.
Yes. So effectively, when the sun crosses the equator of the Earth, the sun is over the equator of the Earth. So those days are going to be equally long.
I see. That makes sense. Okay.
So it's a crossing of the blue line.
Yeah. And the plane of the galaxy, I mean, we're rotating every 100 million years or something around the center of the galaxy. So it's not quite the same thing as the sun moving. So that's fixed. That is genuinely fixed stars as far as we're concerned.
Exactly. The 0 of that red line is the center of the galaxy. And now there is a fourth line, which is the most interesting line, is the horizon. And so the ticks on the horizon are cardinal directions. No, it's the circle, the whole circle around. So that's the horizon.
Yes. Okay. Yeah. Right.
And I have a picture just further down, which illustrates that. If you scroll a little bit. So this is a very nice picture taken from Astronomy Picture of the Day, which is the eclipse of a few weeks ago. And you see, that's the whole horizon. And so on the right, we have how we imitate that very moment. So we also have the horizon. And now we see that this blue thing or grayish thing that we have around is the Earth, actually.
Yes.
And we see the moon, which is covering the sun, at the center. And we see here how we are enlarging the moon, right? The real size of the moon and the sun is much smaller. But in order to make it visible, we make it larger.
Uh-huh.
Okay, so now you see the meaning of this grayish area, which is a new thing in 14.1. So now, can we go up again?
Yes, but I have a question. Can
Yes.
our image processing and projection stuff make that picture from a either
Right.
by stitching or something else?
Right. So I think we must be able to do it. I don't do it yet, but it would be very nice to have some sort of way of texturing the something that looks like the Earth there. But we can do even better, and you will understand it now when we do the next.
Okay. I mean, this is some kind of anamorphic, whatever they're called, and what are those things called? The cylinder projection-y things.
Yes, it's similar. It's a stereographic projection.
Okay, but I mean, this picture makes it clear that it is not completely uninteresting to take an image and do, and treat that image like it's the texture on the surface of the Earth, or treat, and then do stereographic projection on it or something.
Right.
Is that right?
Yeah, exactly. So the circle is the hemisphere above us. The rest is the hemisphere below us.
Yeah.
And so we just have to find an image that can be projected.
Yes.
It has to be an image that includes a 360 degrees. So it's a very special image, but it can be
No,
done.
I understand. Right.
But
That's interesting.
So can we go up? We can do better. You will understand now.
Go further down?
Yes. No, further up. Okay, let's go back again. So move now the altitude scroller, which is the next, the altitude. Yes, exactly. So can we get and check off the Milky Way? So we do, because it's very slow to project the image. So now let's move the altitude.
Yeah.
So you see how that's the Earth. And of course, if you go to very low altitude, so when you have more or less in the middle, we are seeing the horizon.
As a flat horizon.
Exactly. So you can now move the azimuth, and you will just be pointing, the next one, you will be pointing at a different place of the horizon.
But why is the horizon not showing marked off northwest or something like this?
Because the ticks just flipped to below the horizon. That's something that we have to change.
Okay,
I mean, for example, change the elevation now.
Change what?
The elevation. So now we are going upper in space. So the Earth is being pushed down.
Oh, this is really cool. Yeah, I see.
You see, even the moon, if we get very far, even the moon starts getting closer to the Earth.
Yes, I understand. So we could, if I look at this from Jupiter, for example.
Mm-hmm.
So, I mean, so this picture, I could have a similar picture from the surface of Jupiter, yes?
Yes. I'm not sure it's going to work, but yes. So now, before we go there, notice how the Earth now would also admit having a texture there of the Earth. And we could rotate it. So you see how we would have to interpolate from seeing the whole Earth to seeing a place on the Earth with the stereographic projection you were talking about before.
Just for fun, how would I do this from Mars? Let's say I'm on Olympus Mons or something.
Okay, so do you see where it sets your position in the first line?
Yes.
Just add Mars after that. Yeah, so that's that we are observing now from Mars. So now it's red.
Okay, amazing.
Because that's the color we choose for Mars.
Yeah, I understand. So if I go, is that true that Altair, wait a minute, what's the North Star of Mars?
Well, here we are using the horizon frame. So that's the star that you have above from the place you are looking at.
I see.
So for example, you see the last line of the controllers, click equatorial. Right. So now we have lines that are pointing along the equators. Or you can check to ecliptic or galactic. So these are the various lines of the coordinate frames.
Yes. Soon it will be time for us to do a bunch of webinars about this stuff. So we actually, because people will find this really useful.
Yeah, I think having all these ticks now, it helps a lot for orientation. And of course, having the planet in the proper place, it also helps a lot understanding what you're doing.
Right.
And yes, I having the proper texture there would be fantastic. But,
Right.
yeah.
Really cool. Okay. All right. Onward.
Yeah, so those are two new things we can do because we have a new engine for projections in both astrographics and geographics. And it's a lot more careful with big things, right? So handling this big object that we have there, we couldn't do it before.
So you mean Antarctica is going to work better now?
Exactly, and hemispheres and things like that.
Okay, so let's say I say geographics of geoprojection.
Well, I have examples below if you want to see.
Okay, fine.
But before we go to geographics, let's discuss a couple of things here. One is that we need a way of, Jeff keeps complaining that now the Earth is always in the middle. So he wants a way of removing the Earth. And we are suggesting this show nearby objects. Of course, it cannot say Earth because it could be Mars if you are observing from Mars. So what do you think of these show nearby objects false?
Well, I mean, is it a string option really like that?
GeoStyling has a bunch of styling parameters. So this is experimental. It's not set in stone. And I'm not sure having the show in front of all of them makes sense. But we have things like show constellations or not, show.
I see.
Yeah, this sort of thing.
What do you mean by nearby object?
It means that we are observing from a place that has one of these bodies very close. It could be the Earth if we are observing from the surface of the Earth.
Okay, but even if we were from the ISS or something, that would still be a nearby object.
Exactly. So that's the example I have further down. For example, if we observe from the solar system barycenter, the sun is very close. And so the sun looks huge, deformed in the more by the projection, but that's the sun when we are observing from the solar system barycenter.
Right.
And so because it's going to cover a lot of map, it would be nice to be able to remove only that object. We don't want to remove all the objects, right? Like all the planets or all the solar system bodies. Only the nearby.
Well, I mean, basically, it's whatever object isn't shown essentially as just a point or disk or something.
Exactly. So internally, it will work with some sort of threshold of angular size.
Yes.
Everything that is above, I don't know, 30 degrees or something like that, or even less, will not be shown.
Nearby objects. Well, it's not terrible. I mean, I don't have an obvious improvement.
Okay.
Let's see. Yeah, I don't have an obvious improvement.
Mm-hmm. Okay, we'll go with that for a moment.
But
And then
by default, it's true.
It's true, exactly. Because it's there. We want to be able to show it's there.
Right.
Now, with respect to data, so now we have the ability, and this is going to be helpful for cloud, to use lower approximation data so that we don't have to rely on these large files that we download from NASA. So currently, it's an internal option. Sorry,
how far off is it? There's the low precision thing.
How far?
How wrong is the low precision ephemeris?
Oh, it's not very bad. I have an example below for the moon, which is one of the most complicated cases.
Yeah.
And so that's declination. But I was referring to the curve before.
Okay.
So that's an error. So those are years, so 10,000 years either side, and that's an error in degrees. So the moon is half a degree in size. So that's about the size of the moon in 10,000 years.
Okay, so you'll have the eclipse wrong in 10,000 years.
Exactly.
Right.
And the position on the Earth much earlier.
Why? Because the right ascension goes haywire.
Because where the path of totality falls on the Earth is very critical.
Yeah.
It's very dependent on tiny changes of angle.
All right, so we could probably describe high and low precision in terms of eclipse calculation.
Mhm.
In other words, just to give people a sense of what they're signing up for. I mean, in other words, for something that is, where should I point my telescope today? The low precision ephemeris is going to be just fine.
Exactly. Of to do one of these maps like the one we were just looking at, that's going to be totally fine.
Right. But
an occultation or something like that.
well, so hold on a second. I mean, presumably, if we see that somebody is going 10,000 years in the future, we can say you've got to use the high precision ephemeris.
Mhm.
Why don't we have an automatic?
Yep. Well, I was going to ask, I mean, how do we allow the user to control one or the other? For example, with an option, which I'm
Performance
suggesting to call
I would
the
do-
Astro data source or Astro ephemeris.
I wouldn't do that. I would just call it. I mean, that would be like, what's the tile server in Geo called? What is that called?
The GeoServer.
Oh yeah, right. Let's see.
I mean, this could be used, for example, to point to another file that the user has downloaded from NASA or something like that.
Yeah, I understand. Well, I mean, we could be much more ephemeris source or something.
Mhm.
It's kind of redundant to say ephemeris model. I don't like Astro data source. It's too general. I mean, it could be anything.
Mhm.
And these ephemera, these have to be in a very specific format.
Yes. It's basically either tables in a very specific format or collections of orbital elements.
Okay.
Of very specific type.
I'd like to, I mean, if we call it ephemeris and then another word, what should the other word be?
Source could be good.
I don't really like source because that suggests that it's going to be NASA, for example.
I see.
Let's see. Do we have a model? Go ahead.
No, I was going to say data, but it looks like a function rather than an option.
Yeah. Well, I mean, we could just have a method option.
Yes, that's what I write at the end of the first line.
Okay.
We could put it in method. It sounds a bit as of an abuse, but it could be.
Well, it's a method, DE, whatever it is a method. But now I think what we should do is a performance goal.
But honestly, this is not much faster. I mean, the low precision method is based on orbital elements and it requires quite a lot of computation. The NASA data is fully spelled out in terms of Chebyshev polynomials, and it's very fast.
But I mean, but why not? The performance goal would be memory, or
I see what you mean.
Because that's what the issue is. It's size versus, I mean, it's a performance goal arrow. Quality versus size, isn't it?
Mm-hmm.
As opposed to quality versus speed.
Exactly. Yep.
So I think that's what we should do. And then what we should do is automatic should be, I mean, once you've downloaded the high resolution ones, then see, that's another issue. How do you specify that you want to download them? I mean, if you know you're going to be doing a ton of these computations and you don't care about the speed, the size, why not download everything?
Mm-hmm.
What is the mechanism that we have for downloading data caches? preload, right?
Entity prefetch, yeah.
But that's for entity. So
I
so
know.
so so here here by default the files are being downloaded and being placed permanently in one of the users folders.
Yes, I understand. But I'm asking if I want to say, hey, look, I know I'm going to be doing a ton of ephemeris calculations. I might as well be using Chebyshev polynomials. Let's let's bite the bullet and just I'm going to get a cup of coffee and I'm going to download all this stuff. How do you do it?
Sorry, I still don't understand the question. In Astro, that's a default. You don't have to do anything. It's precisely the other way. You have to prevent it.
I understand, but let's say you did prevent it by default.
Mhm.
If you make one query, you don't want to be downloading all that stuff. I mean, arguably, we could start downloading in the background. You make one query, it goes that's of current time, it goes low precision using orbital elements, and then it starts downloading in the background.
Well, it's not a single file. It's more like 100. And so it will download the file that's needed.
No, I get it. I get it. But I mean, I'm saying the initial query, if it's within the time bounds where this small ephemeris will work, just use that. Does that make sense?
But we risk precision. So I think by default, it should still try to download the files.
I see. So you're saying that we should only be able to set performance goal arrows. So I don't like that. I don't like that because if you're just doing a consumer query, a tourist query, and the thing is grinding and downloading files for 10 minutes before it does anything, that's really kind of bad. And nobody's going to know to set performance goal. I mean, unless maybe the progress monitor could give you something that says, don't bother to download this. I only need low precision.
I see.
You know what I'm
saying? I see. So perhaps it can be, I mean, if you're plotting a very large scale map, like the one we had before, we don't need the whole data.
Right. Right, and we certainly don't need to download data for the Pluto ephemeris just because we're going to put Pluto on our map.
Right. I see what you mean.
Okay, so I think there's multiple branches here. One is, if it is downloading the big thing, it should say in the progress monitor, if you don't want the big thing, just press here, and it will just use the small thing. Second thing is, if you're asking for something 20,000 years in the future or whatever, it's got to have the high precision thing, so tough luck. Well, maybe not anything. No, I mean, if you're looking for something, I mean, I think we have to use heuristic to decide what, and even in the cloud where we know we can't use the high precision thing, at least we should give a warning that says this is, using low precision. If you want to know whether the dinosaurs will have seen this, it may not, on Wednesday, it may not be able to tell you that. Right.
So what we are doing currently in the cloud is using 150 years of of high precision. So the file is there permanently from 1900 to 2050.
Yeah, okay, fine.
And then outside that, we will use this other data.
That sounds good to me. I mean, but maybe we should produce a warning saying, using slightly lower precision results. Okay, so wait a minute. So where are we leaving this? We've got a performance goal arrow size that you could set, but probably no user is ever going to know to set it. A performance goal size and another one precision, I think. We shouldn't probably use quality, just precision.
Okay.
And then all right, so what's the default behavior? The default behavior will look at what function you're evaluating, I guess, and see whether it thinks you need high precision.
Right.
Okay, well, we should try it.
Okay, so something else we have added is that there were several domains for which astroposition didn't compute because it didn't have data from NASA. Now it falls back to Wolfram Alpha always. And if Wolfram Alpha has data for strange comets or things like that, it will work.
Good. Okay.
Now, three things that are not necessarily for 14.1, but I just wanted to quickly ask your opinion. We have this function which has been already developed, and it's a function that is working underneath to do these low precision approximations, and it's orbital elements, and it works already quite well. So you can ask for the orbital elements of anybody in any planet or moon around the planet, and it will give you all these results.
Right. These are things that are being computed from an
Yes.
ephemeris, presumably. Yes.
Yes. Yes. From the VSOP, I mean, we can compute it from the NASA data. So these are the so-called instantaneous orbital elements.
Yep.
Which is you fit an orbit to the tabulated positions, and then you report this value. So every time you evaluate this, it's slightly different.
Right. But so eccentricity, I say, what's the eccentricity of the orbit of Mercury? Our entity value system will give me a result.
Right.
But this will give me a much more accurate current result. Is that correct?
Exactly. Yep. This depends on time. So indeed, Wolfram Alpha has tables of fixed values of these things.
Yeah.
Which were taken at some point. So this is real time.
Right. So yeah, I mean, we want this function. Why wouldn't we have it?
So I mean, I was planning to have these together with the whole framework of orbits, which we don't have yet. But this is a piece of functionality which sits on its own, and it's quite ready.
What does that mean? That's the moon around the Earth.
Exactly. So each object has a default center, but you can compute the orbital elements of the moon around the sun. And then, of course, they are going to look like values for the Earth.
Well, how can it be accurate? Isn't this representing an elliptical orbit?
It's representing, this is what I was saying before. It's fitting an elliptic orbit to data around the date you specify.
I see. And how does it tell me how far that will work? I mean, if I go out to a lunar month, it's going to be absolutely hopeless.
Exactly. So this is going to change a lot more than the previous values, because it's not a real orbit. Right.
Yes, I understand. But does it give me a sense of how accurate, how far the elliptic approximation is going to be accurate for?
Oh, I see what you mean. No, there is no parameter, at least right now, that tells you a notion of how stable this orbit is.
Even though you presumably know that because you just did the fit.
Yes, probably there is some way of computing a notion of that, but no, I don't have it right now.
What will we call this function? Is it orbital elements data? What do we think we'll call it?
I think orbital elements or astro-orbital elements to make it an astro member.
I can't imagine what other orbital elements there would be.
Okay, it doesn't sound like chemistry related.
Oh gosh. All right. Okay. Fair point. I mean, the other thing, when we have orbits, I don't know what that will look like. Is there going to be an orbit data? How is it going to work? What are we going to be?
I was thinking of having an astro orbit object that basically represents the whole orbit, and it knows.
I see. It's been fed orbital elements, and then you can query the astro orbit.
Right. Exactly. So in a sense, a set of orbital elements defines an elliptic orbit, assuming they are fixed in time.
Yes, I understand.
The astro orbit will be more general. It will be something that receives dates and returns astro positions. So astro right set is another function that is almost done. We got stuck last time. There is a reference page because we didn't agree how to represent the results. So this is a function that reports the dates of rising and setting of any object observing from anywhere. And the problem here was that it's not clear how to represent both together, risings and settings. You didn't like this proposal I had.
Yeah.
but we didn't find a way of doing something better than this, or the right way of doing this.
Would it make sense to return an association, or does it just get too weird with
And
the
little
case?
associations that say set arrow, whatever, rise arrow, whatever.
Right.
But we want multiple events. I think the point
Right,
is
right. But there's multiple little tiny associations.
Yeah. Okay.
But clearly these are alternating.
yes.
What other things do we have like this? I mean, we have somehow I'm thinking, oh, I mean, this is like a categorical event series. How about Roger, Gosha? Any comments on that? I mean, in other words, we could return this as an event series.
Yeah. And I think in the future, we'll go all out with event series and have them be events where you can store a bunch of other properties that you want around the event. You know, like if it's a server event, you look at log files for a server, they store a whole slew of things around the event, the call event and stuff. And
well,
I think
so
that's
probably an event series is what we want to do here.
I think
That'll
so.
be the least inconsistent. Or alternatively, we could return, I mean, the thing you could feed to an event series would be date arrow set, date arrow rise. And then you could wrap event series around that and have it work.
Right. And also it would be fine in tabular too. These discrete events in a tabular object is really nice.
Right.
And we'll be able to interoperate, embed in
Okay,
tabular.
so I think the basic answer is, Jose, that a list with date, arrow, set, or rise seems probably okay.
I see. Okay. I like that.
With the expectation that it can be turned into an event series.
Mm-hmm.
But now, can you ask it for specifically one thing or the other, the rise or the set?
Not right now, but I mean, I can imagine we can add another argument.
Yeah, it's just got an awful lot of arguments. All right, we probably need a slightly more detailed review of this.
Okay. So the last one is something that appears frequently. We have added a function to report new moon, full moon, etc. And there are many discussions in what you need is the solstices and equinoxes.
Oh, well, they're weird enough names. Why don't we just use them? Solstice, equinox. Next solstice, next. Go ahead.
The four of them, like vernal equinox or solstice, would take two possibilities.
What would the actual names be?
Summer and winter solstice, or vernal and autumn equinox, or spring and autumn equinox.
Okay, and then it just is, how do you get the 1/7 from now type thing?
Right, or from a given date.
Right, but that presumably new moon from
you give a date and yeah. So
okay.
go to
I mean, I
next
think the
first.
same thing can happen with these equinoxes. The only question is it a single function? I mean, my only question would be, presumably these things exist for other planets as well.
Yes, they do.
So those things, unlike new moon, which is like, well, which moon are you talking about type thing,
Mm-hmm.
But the notion of a vernal versus autumnal equinox is not going to be the same for other planets, correct?
The definition, because this is defined in terms of longitude of the sun. I mean, the definition extends. The name will sound weird, yes, because what's winter in Mars?
Right. So the question is whether we want to put the vernal and autumnal in the name of the function or somehow in the argument.
I mean, I guess we can still say, well, winter in the hemisphere that is farther away from the sun, things like that.
What about Uranus, which is tipped upside down or something? I
Right.
guess it doesn't have a surface either, which doesn't help. Well, I mean, mostly people are going to care about the Earth, so probably, we can. I would say preliminarily vernal and autumnal equinox. Vernal, yes. Rather than equinox of vernal, for example. It's more defensive to name it vernal equinox. Right, I'm
And
going to have a quick look here. Go ahead, sorry.
yes, the names I was thinking of spring, summer, vernal, and autumnal. So it should be
autumnal, yeah. That's what people call it, vernal and autumnal equinox.
yes. Okay.
Okay.
Rather than spring and autumn.
Well, I mean, maybe we should go modern rather than 19th century.
Right, because the solstices are going to be summer solstice and winter solstice.
Okay, but let me remind you that in American, it's fall, not autumn.
Oh, okay.
And I've never heard anybody call it the fall equinox. That's a detail. We're going to have to look into this. This is a Jeff thing or whatever. I don't know.
Mm-hmm.
Okay.
Okay. So in Geo, so this is an example again of the new engine, which you can now rotate the Earth and it will not make
that's nice and fast. Okay.
Yeah, and it will not make the arrows cutting the edges on the sides that we were doing before.
Where's the geocenter? Oh, that's lat long. Okay.
Exactly. So you can cut it as well.
Oh, look at Antarctica. It has no seam. Has it not had a seam before?
A what?
A seam. Didn't Antarctica have a seam from its coordinate singularity?
Oh, I think it still has. It's just that it's covered by the grid line.
Oh.
Remove the geogrid lines. Just do geogrid lines goes to none.
Oh dear, oh dear.
I think
somebody's going to be, have a ship, and they're going to think, oh, we can get much closer to the South Pole by going into that little channel.
So that's not the fault of the engine. The data has that. If we remove it from the data, the engine would still be able to write this, to plot this properly.
Yeah, but how do we remove it from the data? It's a coordinate singularity, isn't it?
Well, the problem is that if we remove it from the data, probably Wolfram Alpha will not plot it correctly because it's using the older methods. Okay. Well, so these are very hard cases that we were getting wrong before, because you see how Antarctica is going around the whole Earth.
Yes.
So these very large situations and very deformed situations are now properly handled.
Wow.
And so that's it. The last one is the mnemonic projection.
Yep.
Yeah. So this is the sort of thing which, yeah, for vector cases that were not handled properly before.
How is this? I mean, is this new math or new software engineering or what?
This is a new algorithm to handle primitives. So it's doing the key idea is doing clipping on the sphere. So before I was only able to do clipping on the plane, and so many of the spherical operations were not correct. By doing clipping on the sphere, it helps a lot.
Well, I've seen these, right? These are cool.
Yes. So I just wanted to mention, because we hadn't discussed this, that the next two are very interestingly going to go through Spain.
Okay.
So, and they're both in August. So the weather conditions are going to be properly quite nice. So the first one,
2027. Okay.
Exactly, in August. The first one, the one on the north, that ends in Spain. So it's going to be very late, around 8:30 p.m. And very low with respect to the horizon. So I have an astro map below. And so now you see, now we can always plot the ground, which is very good for our
Oh,
orientation.
that is cool.
And these squares are 5 degrees. So the eclipse is going to happen at 80 degrees or so.
All right. Well, we should start booking the Airbnb or something for the
And the other one is going to be even better and very long, like 6 minutes
wow.
in 27,
Huh.
and much higher in the sky.
Very
So
cool.
I think the maximum is in Luxor in Egypt, and it's going to
Uh-huh.
be like 6.5 minutes there, really long.
Huh. All right. I better go to something else here, but this is really cool. Is there anything else that we need to look at in this meeting?
No, we're just working on adding more formats. That's it.
It's all great. I mean, this is really cool that this is actually solved. This is really nice. That was a
Mhm.
nasty glitch before.
Yep.
All right. Very good. Thanks. And okay. See you all soon.